Hello and welcome to another episode of Hedgehog Makes. My name is Austin, aka Zombie Hedgehog, and today we are going to be starting to wrap up the Micron build. So this is a West3D kit that they're letting me beta test. So this is the first kit, and we're finally going to be installing the bed heater. That was the last part I needed to really get this thing up and running. It's been printing. I've tried some Kapton tape prints and it worked out surprisingly well. I'm happy with the quality of the prints. So today we're going to be installing the heater pad, finishing up any wiring, maybe install some panels, I'm not sure yet. But just kind of install the heater, make sure it works, and try some test prints. So if you're watching on YouTube, this is being recorded live on Twitch, so make sure to check out the link in the video description to catch these live. Make sure to hit the like button and subscribe to the channel while you're there. And for those of you watching live, welcome on in. As always, say 3D printing and making hangout. Feel free to chat and chat, ask any questions, but most importantly, just have a good time. So we have stream elements, collateral damage, little diabeto, Nuno, welcome on in. Mark 8, Twisty Brain, King Hat, Dark Storm, some awesome folks here. So the printer does move, the printer does quad gantry level, and it does print. The only thing it doesn't do is print on the bed without any additional adhesives or whatever the case is. So what I had to do while I was waiting for this heater pad, which was just in transit, I had to use painter's tape and Kapton tape. Both of those they can be used as a bed adhesive. I don't know the specific chemistry or science behind it, but back in old 3D printing times, that's how you would get your prints to stick. So it was quite interesting to use that. I had Kapton tape for printing PETG a long time ago, and I was able to apply it directly to the bed, and it worked out fine. Two-Stroke Texan, welcome on in. Hello. So I made one mistake with that though. I applied the Kapton tape directly to the metal. So not on a flex sheet, onto the metal. So I couldn't flex off the sheets or the prints at all. What I should have done is just put it on the smooth PEI. So this is West3D's build plate that it comes with, which does have indexing pins in the back. I like that. So yeah, I'm very excited to tear apart the bed, install the heater, reinstall it, get it wired up. There's a few things we have to do, and then start printing. Start blue tape, move the glass. Yeah, blue painter's tape seems like a good, well, I wouldn't say good solution, but a good hack. A good hack. All right, so what I'm gonna do is take off the bed. So to do that, there are 4 screws holding on this bed. It's very similar to a 2.4. So we have one right here, one right here. I'm gonna slide those forward. I'll have to reset the position of the bed after anyway. It doesn't really matter. Take off this one and then this one. So just gonna take this bed completely off. Right now it's just a big hunk of aluminum. So now that I have that, we can start the silicone pad process. So typically you do this first, but I've done it second, so not a big deal. What you need to do first before you do anything is clean the bed. This is a high temp sticker. You need to be able to, have a really good adhesion. You don't want it to come off. It does have a protection built in with a, actually this wouldn't even have one. I don't know if this bed has a built-in fuse. I'll have to verify. But it's a 100 watt or 120 volt, 300 watt bed. So for now, I'm gonna wire it directly back to the build plate, but we can look in the future and see if we need to add anything else. And for this whole entire series, if you're just tuning in, this is a beta build. This is not strictly a build guide, but it is a reference that you can use for specific parts. I would follow the the official Micron guide. If you're interested in that, there is a Discord. I'll have that linked in the video down below. So I'm going to spray it with some isopropyl alcohol, and this will just help with any oils on here, and then any loose dust. We don't want anything on here. Just a quick, yeah, see look how dirty that is. That's just black. So give it a good little scrubbing just to get all that off. If I was being really proper, I'd bring it up to the kitchen and wipe it off with some dish soap and hot water. So if you're watching episode 4 and you immediately start watching this, you'll notice that I have some changes to the channel. I now have an overhead camera right here. So this allowed me to do some overhead shots. I'm still working on the positioning and stuff like that. I think I have a new mouse pad. A lot of things are new. So it's been a fun time transitioning and you know, making the studio better. Hopefully I can get some better angles and just provide better content for you. Welcome in, Sir Squishy. Yeah, so this is a West3D kit. So this is a very much, not self-sourced, but fully sourced by West3D kit. So everything that they're including is all custom. So this is an LDO kit. It's not a like a foreign bought kit. It is a West3D kit. So you know that they're going to pick out some good components, and they've had a really good balance of quality and cost. That's what I found with this kit. So far, it's really nice. The actual construction went together well. All the parts they included were good, and I'm overall happy. And I provided, you know, some basic feedback on maybe some stuff that's missing, some stuff I changed. So some of the parts you've seen in the build might change for the final release, or they might change over time. Who knows? So make sure to check in on the West3D website, west3d.com/zombiehedgehog. That is my affiliate link, and you'll be able to see any updates. So for the actual heated bed installation, there's 2 options. Number 1, you can install this as a 2.4 with the 4 screws, or you can install it like a trident with the 3 screws. As I'm touching this with my fingers, I shouldn't be doing that, but so those are the 2 different mounting points. So in the future, if there's a, I don't know, 180mm salad fork, you could use this bed as well. So the heater pad is also set up for that. So I did check it, and it does clear all the holes, so we should be good there. So the first thing I like to do is I also clean off the back of this sheet, just in case there's dirt, and I rest it on. Without the adhesive cover removed, rest it on, and make sure that it is completely covering everything, that it's lined up correct, that you're not overhanging on one side, that you're not crooked. Get a general sense of how it's going to look. So in my case, I am slightly inset from all the edges. I'm not on the edge on any side. I have a little bit of a gap, and you can see that here. So a small gap. So what I'm going to do is start on one side. I think it'd be easy if I do this one, and peel off some of the sticker. Stick a little bit of the sticker, and then line it back up as I'm holding it down. So line it back up, use the back, line it up, get one of the sides lined up, and just make sure that it's really, really lined up. And then make sure this front is lined up, and then press down on the front edge right here. So just this front right here. So that's the only thing stuck to it right now, is just this front. Then I like to press down in the middle, and then kind of peel it up so I can get at that sticker, whatever you call the backing. And then I'm going to just slowly press this down, working my way this way to remove any bubbles. So you don't want to have any bubbles form. So work our way back and forth, pressing down reasonably hard with my fingers, and then just force it down on the build plate. Again, making sure there's no bubble buildup. There's a better angle. So ideally you would use a laminate roller. Just provides a lot of pressure as a roller, but this will be fine for what we're using it for. And we'll go back over with our hands and just make sure that it's reasonably on there. And then ideally you would let this adhesive sit before use. In my case, I'm not going to, but I do recommend applying this maybe the day before you're going to use or install it on the printer. Do it at the very beginning of the build maybe. Just get the heater pad installed, get the magnet installed, so by the time you go to use it, all the glue has cured, etc. So now you can take anything. Let's take this bottle of glue, for instance, and then just, work in the material, focusing on the edges. You want to really get the edges pressed down. That's the most important thing, is all these little edges. And then in the middle too. So the edges, you don't want it to peel up and then fall down. So I would say this is a fairly typical installation, and that worked out well. Hello, Hybrid Robotics, Cybernet, Lizard Breath, anyone else might have joined in, Thunder Keys. If I missed any comments, just repost them. You like the configuration kit? Yeah, so this is a new kit. Let me actually bring it up on their website so we can go over it. So if you go to west3d.com/zombie hedgehog, right here, then you can see right on the front page right now, there's the Micron Plus configurator. So you click that, and that brings you here. And the base kit is $800 US. And that comes with everything that you need to do the build. But of course, there are upgrades they might want to do. The frame, you can get whatever color you want. DLL PDF will make a custom, I think it's powder-coated frame of whatever color. So if you wanted it to be purple, then you can have a purple frame. So for now, we'll stick with black. Printed parts, you can get West3D to print them all for you. There's a lot of parts, an actual surprising amount of parts. So if you'd rather just have them do all the printing, you can choose one of their new ASA ambrosia filaments in are these all Galaxy? There's a lot of Galaxy colors. They look really good. So for the extruder, you can choose just BMG gears. In my build, I'm using a sailfin, which is similar to a Sherpa Mini. So you can use the regular hardened steel gears and just build your own extruder, print it. You can choose to upgrade. I probably get the nano-coated gears. I think they have extra wear resistance. Useful if you're printing abrasives, you'll want the nano-coated on it. But then you can upgrade and get orbiter, so a straight up orbiter. That's what I typically use on my printers, and it's more plug and play. So you just, put it on the printer and it works, no assembling. And then Galileo 2 is a new option, which is similar to orbiter, but you get to build it yourself, and maybe slightly higher performance than orbiter. But if you're kind of on the fence with all these, I might just default to an orbiter too. For a tool head, I would strongly recommend Dragon Burner. It's going to give you better cooling, going to give you more compatibility with different hot ends, and it's just really nice to work on. So I'll go with Dragon Burner. For a hot end, it actually comes with a Rapido high flow. That's pretty awesome. You can choose to upgrade to another Rapido. So if you wanted a ultra high flow, and this is a Rapido 2, by the way, you can choose to get a high flow with a PT 1000 or the ultra high flow. But for this case, you're probably going to want to go with the Rapido high flow or the Revo Voron edition. So either one of those. Revo, not as high performance, but you do have the option to change out your nozzles with 5 seconds. So it's pretty nice for that. Depending on what you want to use this printer for, I'll be using it for more of a single color, high performance prototype printer, maybe my travel printer, so that would make sense to go with Rapido. For the probe, I will strongly recommend upgrading to either PCB Clicky or Boop. PCB Clicky is just a dockable probe. that magnetically attaches to the tool head. So that's an option, or boop. Boop is what I currently have installed. It's very similar to tap, just smaller, and that allows you to use the nozzle as an end stop. It's incredibly nice, so that's what I would do, and it doesn't actually impact the performance of the printer. I'm able to push this currently with conservative settings, 600 millimeters a second at 20K acceleration. And it has more it can go if I push up the currents, so boop, perfectly fine. The build plate, you can either choose the stock or get a mag bed. For only 30 bucks more, might be a good option, not having to deal with a magnet. Just the magnets are built into the bed. I'll stick with the Mic 6 plate for now. Motion, you can choose to go all out and get gates, pulleys, idlers, and high temp belts, as well as the Berserker kit. So this gives you even smoother bearings. I've used the Berserker motion system on my 2.4, and man, that is super smooth. It is surprisingly noticeable how much smoother the gantry moves compared to standard bearings. So for now, and the Z drive, you can get Galileo Z, but I'm gonna stick with the standard Z. I'm just gonna add boop, Dragon Burner, and Orbiter. And that's what I would probably go with if I had to pick. And then of course the Panasonic relay will be fine too. So the total price will add $50 to the $800. So we're looking at $850. There we go. And is it worth it? Well, that's a question that you're gonna have to answer, because I've had people ask, oh, should I do this, or should I build a Trident? Should I build a 2.4? If this is your first custom printer, you might want to get something bigger to start off with. A 300 Trident or a 300 2.4 is a really good option. That'll allow you to have a printer that you can print just about anything on, and then maybe have this as your second printer. The one that kind of just does most of your printing, because let's face it, most prints will fit on this build plate. Like pretty much all my prints would fit on here, besides a couple of them. Pin my affiliate links. I have all my affiliate links posted in the Discord. If you want me to add additional ones, let me know. Does it come with a wiring harness? It does. In fact, let's take a look at the wiring. I think we're gonna have to do that pretty much next. So I'm gonna flip over the printer. I currently don't have any panels on right now, besides the bottom one. So I'll have to, let me just cut this filament out too, so it's not dangling. I forgot to do that when I had it heated up. So remove this filament, and then I'm gonna flip over the printer. It's very easy to work on because it's so small. So you can essentially just flip it over, and then on a desk, you can look into the electronics bay. So let me take off the panel and I'll show you what I've done for electronics, and let's try to fix it. Welcome in, Turtle. Yes, we're talking about specifically the Micron Plus. I've said this many times on previous episodes, but this is probably the best valued small form factor printer. So it's 180 millimeters by 180 millimeters by around 150 to 160, depending on what tool head you go with. In my case, if I had it fully enclosed stock, I get 150 millimeters on the Z-axis. So let's just say 180 by 180 by 150, or slightly greater, for a little bit more than a V0. Depending on what kit you get, it can only be a couple $100 more than a V0. And you get much bigger size. It's not that much bigger than a V0. Like this guy right here is a little bit, it's a little less wide and deep, but this is not much bigger. So if I had to pick between a V0 and a Micron Plus as a travel printer, well, I go with this one all day, honestly. And I do plan on potentially bringing this to Rocky Mountain Rip Rap Festival. And I'm not going to mention it here, but we may or may not be doing a special mod to this once it's done and the beta is over. We'll do a very special mod. So tune into my live streams. We could talk about that. Actually, we'll discuss that in the after party after the stream's over on Twitch. All right, I'll show you what I've done. I don't know if I would specifically recommend this, and I can't say that this is going to be the final wiring, but for now, yeah, it's a rat's nest. It's a very small area. I couldn't imagine a Micron regular, the 120 version. So this is what I've done for now. We're going to have to manage it. But I've just taken this quite long wire loom and wrap it around a few times. And I've kind of pressed up the panel against it. Eventually, it's probably going to be wrapped up and put probably in here somewhere. I haven't fully tightened up everything yet, but we'll make a nice clean wiring area for it. There's actually a lot of room underneath this power supply, so all these cables are probably going to live under the power supply. Recrimping might be a good idea. I would not recommend recrimping if you do not have to. That's one added point of failure, and it's a lot of work. So leave everything as is, and just kind of tuck the wires out of the way. But how this wiring generally works is we have our inlet right here, and then the wires for the printer's off right now, so I can touch it. The wires to the high voltage comes into this little Wago connector here. Then that will feed into the power supply. On the other side here, we have our 24 volts out. Then that goes directly into the board here. And then the board is actually feeding the Raspberry Pi. So this is a Octopus board, and I have the Pi connector here. I've actually made this one. The kit should include a power connector, to be determined. But I've made a little bit of a harness for this. I'm gonna have to make some of my own wires because the wiring did get updated slightly after I built this. But yes, this has a lot of extra wire, which is a good thing. It's good to have more than less. So I will do a cleanup, and then maybe in the final video, I'll show you what I've done for the layout, take pictures of it, etc. Maybe just like a quick overview once it's printing ABS. So right now, we're gonna take this bed and run the wires. So it has a zip tie. Let me get not a zip tie, but the wires are bundled up. I'm just gonna feed them through the slot as if I was installing it from the other side. So the slot is over here. So I'm gonna take the bed and then just feed the wires up into here. The wires are extra long, which is good if you have a Trident style, or in the later case, the salad fork. They'll be long enough for that. Electronics fans. So it does have two 4010 blowers on this side, and it's just enough air to keep everything reasonably cool. Before I installed them, I was getting some overtemp errors on the Pi because it doesn't have any cooling on it. And then after, I was not getting those, so it did work. I just gotta find this hole. It's down here. I'm gonna feed them up through here, just like that. So these are my wires for the heat bed. So I have two wires that are thick and then two wires that are small. The thick ones are the bed power, and the small ones are for the thermistor. Now do note that nothing that I'm saying right now is what you should be doing for your build. You know, if you wire the printer according to the wiring guide. I have to give that disclaimer because we're working with high voltage here. So the general way of wiring this is I'm going to strip back one of these sides 11 millimeters. Use my other stripper. If I can find it. In the meantime, I've also been building another printer, the 2.4 tap changer, stealth changer, the Voron tool changer, little tagline I made up. Yeah, so I've been doing a lot of work on that. So all my tools are in random places, but I've been getting more organized. So that's good. 2024 has given me better organization. So we're gonna cut this back a little bit. And then if you ever have any, if I can actually get this on camera, if you're ever cutting your wire, you see how there's some white strands? You don't want that to ever go onto your connector. So if you have those, take your wire snip or your side cutters and then just cut off the little snips of insulation. Just like that. And then always make sure to twist your stranded wires clockwise. Just like that. That's generally good. So now we're gonna take this and one of them is gonna go right into the main power. So the cable that goes into the main, into this Wago port, which is always gonna receive whatever power this is, we're gonna hook this up to the neutral. So in my case, the neutral is black and the line is red. So I want to hook it up to one of these black connectors right here. So this means when the printer is on and not heating, the voltage on this wire is neutral. Otherwise, the voltage on it would be hot. So if something did happen, like a short, this would be, the whole bed itself would be neutral instead of hot. That's the idea. Well, it shouldn't happen, but you know, we want to just use our best wiring practices when we do these types of things. So that's on there, it goes right into the Wago. And then the other one, now this should, ideally this would be terminated with a spade connector. But what we're gonna do is, again, cut off a little bit of it, just a little bit more on this version. And this is gonna go right to our relay. So right here is the output of our relay. We have the input right here, which is our DC input, essentially the output of the controller board. And on this side, we have our load. So on one of the sides, we're gonna hook up our load. It doesn't matter which one, because one of them is gonna be fed in from the power, and the other one is gonna be feeding to the bed. So the way the circuit works is power goes into the terminal here, into one of the sides of the relay. The relay acts as a switch. The other side goes to the heated bed, and then the return from the heated bed goes straight back into the Wago, and then back out to mains. And then this right here is gonna do the actual switching for the power, or for the heated bed. Service loop, yeah, we got quite the service loop. Where's the Micron Plus? It is on the front page. I don't think it has a category yet, but it's on the front page. If you go home, it should be the first thing on there. Great things come in smaller packages. And the mag bed is, I have it on my Twisted T, but essentially it's just some neodymium magnets built into the bed that you don't need that stick-on magnet for. All right, so what I'm gonna do here is loosen up one of these screws. And there's multiple ways of installing these wires, but I'm gonna be installing it with just bare wire. If you're doing this, make sure to be careful that all of the strands are twisted, it's very clean, and make sure there is no exposed wire on the outside. So we're gonna stick this in under one of the sides. This is gonna go under that little plate, and then we're gonna screw it down. We're gonna make sure not to screw down onto the insulation. You should only be screwing onto metal, the metal of the wire. So that should be plenty. And there we go, we have our connection to the bed. We'll do proper cable management later, but for now, this will be manageable. It's not ideal, but it'll be fine for now. But if we wanted to, we could just snip this, then make the actual wire shorter when it's done. But better to leave it long. Yes, I'm using my insulated WeHa driver. I like to go on Amazon and buy just random cheap drivers because they only cost like $5-6 each. So it's fun to have a small collection. For example, I really like these mini drivers. These are about like $6, maybe $8 each. And I use these almost daily. So super useful to have. I have them in 2, 2.5, and 3mm. And in the 2 and 2.5, I also have a ball end version for those hard to get to fasteners. Pretty useful. Eventually we'll have to do an episode just tools because I've collected a fair amount of tools and they're all very specific. Next, we're gonna finish up the wiring on the relay. So we need to hook up this right here to this. Pretty simple. So that is just gonna be we've hooked up to the neutral, so we need to go from the hot to here. And currently, the wiring kit the one that I have does not include that cable, but I do have some spare cable. If you are building a 3D printer, I strongly recommend getting wire. You will need wire at one point or another. I guarantee it. So just having some random assortments of lengths of wire, definitely recommended. For specific recommendations, you know, there's so many different types of wire and their applications. We can have a discussion over on my Discord. Links are in the video description. So I won't give any specific recommendations, but silicone wire is fine for wiring underneath the bed if you have silicone wire. Otherwise, if you're going through a drag chain, you'll need to get literally anything that's not silicone. So I'm gonna take some of this wire I have here. This is actually FEP from Lineo. I'm gonna cut a small length of it and then just make my own little wire. Your final kit should have all of the wiring for that. And I'll double check the BOM before, or I'll just verify. I want to verify that all this stuff is included, but right now I have to make some wires. Beta kit. It's a beta kit. I was fully expecting to do some work on this. So the current wire that I'm using, if you're interested, is 18 gauge. 18 gauge is perfectly sufficient for a 300 watt bed. Perfectly sufficient. I typically like to wire up my beds though with 16 gauge just to be safe. There we go. I have just two sections of the wire just stripped. I'm not using any fancy connections. So I'm gonna put this into, again, the Wago. Which one's the spare slot? This one right here. There we go. I didn't actually put it down. Make sure that none of the strands are leaving. This whole thing isn't screwed down yet, so I have to go back in and really tidy up and clean up everything. But I wanted to just make sure I would be able to build the printer, so I left everything a little bit loosey-goosey down here. So again, do not use this as a specific reference, but if you have any questions on how I did stuff, please ask and I should be able to give an answer. Once again, as we screw this down, we're going to make sure that it's not screwing onto the insulation, it's screwing onto the actual wire. Make sure it's nice and tight. Make sure both of these are nice and tight. Perfect. So now our bed is wired on the hot side. Great. Next step is making our thermistor cable. So this bed does come with bare wires, so we're going to have to crimp on a connection. So bed thermistors are very, very, very simple, and I can show you down here. So all we need are some JST XHs. These are standard, what you call a fan connector. So all we're going to do is take this and then crimp that onto the wire here. So before we start, I'm noticing that these wires are way too long. In order to do a JST, they need to be a lot shorter. So I'll typically cut them down, what is that, until they're no more than 3 millimeters after it's cut. I don't know the exact measure, it might be like 2 millimeters, but it does not have to be long. It'll seem like it's way too short, and that is correct. That's about how much you need. So the way that these crimps work, you have one half of the connector crimping onto the wire, then the other half of the connector crimping onto the insulation. And I have a tool that does both of them at once. This is my preferred crimper, the iCrimp IWS 3220M. Previously, oh man, I don't even remember the brand now. What was the brand of this? iWis. So I love these, they work really good. What I'll typically do is take the JST connector and I'll insert it into the hole. And you pick the hole based off of your wire. I go by insulation size, so I'm using really thin insulation wire, so I can use the second slot. I don't know if there's an actual science to that, but that's what I do. And I go, so it's one click in, so it holds in place. So now we have our connector actually in the jaw, ready to receive the wire. Then I can take my wire that I've already made the right size, and then we have to be careful. Typically, I'll be able to insert the wire so it bottoms out, but you'll be able to see the wire poking on the other side. You want to back it up so it's just barely poking out. Typically, if you press this in all the way, the insulation will bottom out, but we're going to just press down on it as hard as we can because it's ratcheting, so it can't physically move more than that. And then release it, and we should be good. We'll notice that we're crimped on the insulation. The crimp looks good, looks clean. That's a perfect crimp. Perfect crimp every time. So we're gonna put that aside and then do the other one. Same thing. Get used to this. If you don't own a crimper, if you don't own just a assortment of JSTs, yeah, that's gonna be one of the tools I'm gonna have to recommend. Because you'll be making a lot of wires. If you ever want to modify something, you might need custom wires. So having wires, ways to crimp wires, and soldering stuff. There's quite a bit that you can get. What I don't recommend is buying pre-done wires if you can. So for example, a fan extension. If you needed a special cable just to extend a fan, you're probably gonna spend 10 bucks on it. That's great, but it would cost you about, quite literally 10 cents in material to make that same cable if you had the wire, the crimper, and the crimping stuff. So it's usually worth making your own wires, usually. Now, if you're talking about an entire wiring harness for a 3D printer, that's completely different. Having that all done for you saves you a ton of time. You know, making, let's say, 100 crimps and cuts, and it's not fun. Not what I consider fun to make a wiring harness. A couple things here and there, yeah, this is fun. So this is a thermistor. Thermistors, the bed thermistor specifically, this has no polarity. It is a resistor, right? So it does not matter which slot we put in to this connector. But, and this is very important, if this was a fan, we would need to make sure that it is plugged in 100,000% correct, because you can't have reverse polarity in a fan. So what I'll typically do, let's say this was plugged into a fan, spoiler alert, it was. You can take this connector right here and keep this part, the one that's pre-crimped. So when you go to make your new one, you know exactly which slots insert the black and which slots insert the red. That's a bit of a tip for you. Don't just memorize it based off of the plug. Actually I like to look at another connector, specifically the one that I just took it off from. So that's how you would do a fan, but this is just a thermistor. All right, so this is the bed thermistor. So we'll need to get that plugged in. And I am going to reference the handy dandy chart. I'm 90% sure it's this pin right here, but let me just pull it up on my side. Which I think it already is, actually. Is this another octopus board? Yeah, it is. I was using the same sheet for my 2.4. Check the pin out the main board too. Yes, it's usually worth checking both of them. So this is the pinout of the octopus, probably one of the oldest boards that VictorTech still has and hasn't updated the pinout from. So we are probably looking at, yeah, so this part right here. So TB, thermistor bed. We have thermistor bed. Then we have thermistor 0, thermistor 1, thermistor 2, and then thermistor 3. So this board does support 4 hot ends straight off of the board. So the first one is usually the bed, and then the other ones are for your hot ends. So in this case, we're using T0 for our tool head, and then thermistor bed, which is right here. So these 5 slots, and we're going to be plugged into this one. Welcome in, Maker Viking. Cucho, Sebas, Bryce, everyone, welcome in. I tend not to read off who comes in unless you specifically wave hi. Ramon, I see you there. Otherwise, I don't know who's actually been here. I might say hello to you 10 times. And if you're watching this on YouTube, this is not live. This is pre-recorded. But you can still like that smash button. Like the smash button. Did I really just say that? Wow. Wow, I watched too much Nero. That's funny. Hit the like button. Make sure to subscribe. Lots of content like this in the future. We have some crazy builds coming up that you will not want to miss. So this one right here, be plugged in right to this slot right there. We verified it on the pinout, and just from experience, I know where this is. But it's important to know why you plug in stuff, how it is. And for now, this wire is going to sit here, but we're going to have to do some cable management at a later date. I'll probably do that off stream and then show you the final result, because I don't know. I have a couple of ideas, but there's not much space to work with here. This ain't no typical Trident or 2.4. All right, so what's next? I think the last thing that we have to wire up is the relay. So let me see. I don't know what's going on here, but it came with these two connectors here. I don't know what that was intended to be for. All right, so what I think is going to happen is, let me check the config. I don't know if there is a specific config for this printer, but let me see what I have here. And then we'll go from there. Oh, it's not plugged in. Shoot. That's okay. So you can either run your bed with a relay. You can run it off of the main bed port, or you can plug it into a hot end output. Now, since this is just a relay, we don't have to use this big, beefy bed out. And we can actually use the bed out for a hot end if we wanted to. That's how LZO has done it. So for this build, and I think because the wires are short, yeah, we could plug into the bed. I think we'll do that for here. But you could plug it into one of these heater outputs that are over here, and then just configure that in the firmware. So for now, I'm going to attempt to get this in here. It's not the right connector for what I'm trying to do. That's why I was thinking that I would just plug it into one of those, but we'll put it into the bed output. Oh, I don't have any bed power. Know what? No, it's not designed for that at all. Yeah, I don't have any bed power input, so yeah, we're gonna hook it up to HE1. So HE0 is our, these are the gray pins down here. This is our hot end, and then we're going to plug it into the next one. So for this one, polarity does matter, so pay attention. It's labeled pretty cleanly on the board, but we'll want to make sure to follow that. So we'll start with the red wire, which is our positive, and plug that in. Did I unscrew that enough? No, not enough. These are very important. All these screw terminals, you want to make sure to unscrew it enough so you actually get the screw in the correct way. Because you can actually insert it on the bottom, you'll kind of assume that it's in, but it should just pop right out because it's not. It needs to insert towards the top. And then you tighten it. So you actually have to screw righty-tighty to screw it in. If you're trying to tighten it by going lefty-loosey, you've done something wrong. All right, so that's perfect. So keep a mental note that our HE1 is our bed. Get that nice and tight. And theoretically, we are done all of the main wiring. Besides cleanup, I don't have any LEDs on here yet. I do have a couple of the small LEDs to install. West3D did send those over as a bonus, so I'll be installing them after, but I wanted to get this thing built first. All right. Well, now we're gonna see if it works. Now, one more thing. We have to reinstall the bed. That's probably an important task. So I've just had the bed like this. So you'll probably install the bed first before you install any of the electronics and have that already wired up. Or you can install it after the fact, doesn't really matter. But we do have to tilt it. And then make sure the bed doesn't fall. And then make sure that all these wires that are just sitting here, eventually they'll be zip tied and they'll all be managed. But I'm just gonna gently place the printer on the wires. And then take this bed and run it down and put it down. There we go. Move the gantry back, and now I can actually install the bed. So the back of the bed has these two little screw indexing points, the little ears. That's the back of the bed. So what I'm gonna do is just push all the cables into the printer. You'll probably have to go on the other side and pull them through, but you'll need to push all of the excess cable right into the little hole cut out here. For now, we're just gonna get it installed. So I don't have an exact measurement of where these are supposed to go. So I'm gonna kind of eyeball it and then go from there. I'll show you how to align it later, but we just wanna get this installed. So getting all the wires out of the way, we're going to slide in the bed into these four screws. If you have a different bed, the installation might be different. This is the West3D kit if you're trying to follow along for another one. This is the bed that they include. It should be approximately here. You can kind of guess by pushing your printer all the way back, and the nozzle should line up with the back edge. So I think I have to go a little bit further. We're not using a nozzle end stop, so I want to make sure that we can get our full print volume out of here. So the nozzle should be kind of centered over the back here. So if we pull it forward, the nozzle should be at least able to move past the front. So we have wiggle room on both sides. So I'm gonna screw it down. This would also be a good point to get it aligned to your bed. You wanna make sure that the bed itself is square just so you get your maximum build volume. It doesn't really matter. It's a 2.4. You're building on the bed, so it doesn't matter if it's perfectly even. This does have boop, yes. So we are going to just take some 1, 2, 3 blocks, stand them right up, and let's get a very, very rough approximation of squareness. You know, kind of line it up and say, okay, yeah, it looks good enough. We can adjust it later if needed. There we go. Get that one in too. And this bed will be tightened pretty tight. No reason not to, I don't think, for this size printer. On a regular 2.4, you actually want to keep, I think, 2 of them or 3 of them loose, so it has room for expansion. You shouldn't actually rigid mount any bed. You should have some thermal expansion capabilities. So now it is pretty much wired. The last step I'm going to do is tilt it this way. Whoops, not on the screen, ideally. Tilt it this way and grab all this wire and pull it. Pull it, all the excess wire. There we go. So that all the wire is underneath the bed. Perfect. And then very carefully, just kind of do that for now. We like bottom panels. We need to have a bottom panel on here, but for now it's just gonna kind of rest. And now we can start printing. So let's make sure the bed is actually configured properly and that it works. We'll have to PID tune it. So I'm gonna put back on my sheet and go into Clipper. So let's turn on the printer by plugging it in. That's usually a good first step. We get power, that's good. Swatch truck, yeah, we can print a swatch truck first. I like that idea. Typically on these build streams, the episode that I print at, I'm printing like, I don't know, 3 hours into the build, so I don't want to print anything super long. So we can start by printing a small swatch truck and then move into something bigger. I've already tested the printer with Kapton tape, so it does work and it works well. So we can go right into some of the larger prints. This is a Core XY printer. So the kinematics, there's 2 motors mounted on the back right here. So motor A and the motor B. And then the whole thing is linked up with wires that go along pulleys in the front. So this is considered Core XY, much like the modern printers, Creality, Bamboo, etc. They're all gonna be Core XY. That's kind of the easiest way to make a fast printer. There's other mechanics, but this is definitely the most popular. All right, let me log into Clipper. It's all set up. And then I'm just gonna look at it on my end real quick. See if I can find the bed. So right now, this is our heater bed section. If you do not have a heater bed, you can just comment it out and then Clipper will ignore it. But I do, so I'm gonna re-enable it. So highlight all the stuff and then control question mark. Control question mark is a block comment in Clipper, very useful. The Micron Plus does have a flying gantry. It's essentially a small 2.4. So I'll show you how that works in a second. Max power, we don't need to have a max power limit on this printer because it's such a small heater, it's only a 300 watt heater. So we can set the max power to 1. We want to use every single one of those watts to heat the bed. Max temp 120, that's perfectly fine. The control PID, we're gonna PID tune it. But the most important thing is the heater pin and then the sensor type. So this is actually I don't know what the sensor type is, but typically on these types of beds, it is a generic 3950, but I will have to confirm with West3D what the sensor type is. I will do that right now. All right. What's what's cool? Live feedback. So I'm gonna assume it's that. We'll quickly know if it's not. But the heater pin. This is the most important thing. So let's just verify in our output what the heater pin is. So we have the bed out is typically PA1, and that's what it was set to, where the heater, the hot end output is PA2 and then PA3. So we're actually using PA3 because we have it plugged in down here. So that's one deviation from whatever config this is. So we're gonna set the PA3. And the sensor pin should be the same. Yeah, I say control question because there's multiple slashes. And it's easier to see a question mark. So yeah, then we're gonna save and restart. I've only added the bed and we'll see if it works. So if all goes well, we should see a thermistor reading. And we do, 19.8. That's, if the extruder and heat bed are about the same, then it's probably configured correctly, or at least correct enough to where idle's correct. You'll want to make sure that you have the correct thermistor type though. So now we can do a PID tune. I already have a macro that's set to PID tune at 60C, so I'm going to click that and the temperature is going up. Now, this is very exciting. Let's watch it PID tune. This is probably the best content you'll see on this channel. Ready? Let me get lined up. So it's currently PID tuning. Look at that go. Isn't that crazy? For context, that was a joke. Because all it is doing is heating up and cooling down the bed. Typically it takes a while, but we are already at 60C. Wow, that was really quick. Damn. That's a perfect size heater for this bed. Typically, it can take 10 minutes on a 350 2.4 to PID tune, but it's already doing the first cycle. Nice. I know. So this will be really quick to heat soak the bed. It's a really quick printer. I think this heats up faster than a V0. A V0 heater is only 60 watts by default. And then of course you can get the LDO heater that's 100 watts. But silicone pad is gonna be probably the best heater system that you can go with. Some people say it's still tuning this day. It'll be done pretty soon. So yes, this is Drag and Burner. This is Drag and Burner with boop. So the whole entire mechanism goes up and down a little bit, but it's still constrained enough to where that movement doesn't affect the print quality. V0 wasn't an AC bed, yeah, but it's still a low power heater. So yeah, we're running Drag and Burner, and then this is with the, zoom out a bit. This is with the, what do you call this? Sail fin. There we go. It's literally on there. You can read it. Sail fin extruder. Why? Well, I want to try something different, and I had BMG gears that were provided with this, so I picked a sail fin. You might want to pick a Sherpa Mini, so I'd recommend Sherpa Mini or sail fin. Probably Sherpa Mini, to be honest, but this one worked out fine. And the PID tune is almost done, actually, so let's figure out what we want to print. So let's go into the slicer, and I will be providing, assuming that I can, I'll be providing a profile for Orca Slicer for this, so you can get a head start. And I'll be providing all of my Clipper config as well once that's completed. If you're looking for it, just go to my Discord and send me a message on there, or search and it might be there. Who knows when you're watching this video. Let's go to browsing, and we are going to do a swatch truck. So let's do a new project, switch over to our Micron Plus. Currently I have a special profile that says no heat because I have the bed set to 0. So let's do the same thing, but we'll heat the bed back up. Yeah, so bed temperature, we will do, for a large or a thick bed, I like to do my first temperature at 65°C and then reduce it to 55°C. So what'll happen is it'll spend extra time heat soaking because it heats up to that higher temperature, but then it just maintains a lower temperature to keep adhesion. So I think that's perfectly fine. We're going to do a full flow test and stuff to tune the printer. I'm printing at 220°C for now. We can raise it if we need to. I'll have to calibrate the flow even more, but it should be close enough. And I'm going to save this as just Micron Plus because I have a heated bed now. Yay. All right. And then I have a quality profile set up. I'm not going to go through all the features, but let me import a swatch truck. Swatch truck. I have all my commonly used files here. Here's a swatch truck. As you might notice in the slicer, we do have the bed. So this is right in the Micron repository. But here's the actual bed, and that's what it looks like. It's kind of cool. You don't have to import that if you don't want to, but I think it's a cool feature. And that every time I load this profile, I immediately know, hey, this is a Micron because it has this layout. So here's a swatch truck. When I print them for the first time, I like to increase my infill. Let's just do 20%. And then my top surface layers, let's do 10. So what this is going to do is it's going to print off a couple layers, then switch to a pretty dense infill, and then it's going to do 10 solid layers. Any over extrusion will be pushed off to the top surface, and we should be able to see it. This is the same printer you've been building for the last month. This is the Micron Plus, so I was working on it before the tap changer. This printer right here is what I've been working on. It's kind of a larger version of it. Yeah, 2.4 is a larger version of a Micron Plus. That's definitely what it is. No, but this is the printer that it's based off of. This is a 350mm printer, and this is a 180, much smaller. So I will actually have to unload my filament because I cut it. So what filament should I use to test? I'm using PLA. Give me a color. I'll see if I can find it. Do I have an unload filament button? I do. I don't know what it does yet. Oh, and I gotta save config once I'm done. Blue, pink, neon brown, black, pink, pink. Let's see. Let's see what I have for pink. I like to use regular PLA. Let's do this. Let's use some Starlight Nebula. Test out. Starlight Nebula. So it's kind of a purplish, kind of gray color. That'll be fun. Now I don't have any of West3D's Ambrosia PLA yet. Hoping to soon, but I haven't ordered it yet. I have to do that. But I have used their ASA for this build. The blue is their Ambrosia ASA, and the gray is Polymaker's Galaxy Dark Gray. I still got a few more things to print, and I have to find all of the panel clips and install them. I'll do that off stream. I was thinking about maybe installing the back panel on today, but you really just want to see it print, right? What size nozzle? I use 0.4 for pretty much everything. I've also used 0.5, but I typically prefer 0.4 from going for standard prints. A 0.5 is better if, actually 0.5 is probably the best size nozzle, because with a 0.4, 3 walls gives you a minimum of 1.2 millimeter wall thickness, but a 0.5 nozzle means you can go and have a 1 millimeter wall, or slightly extrude, make the lines wider, increase your line thickness, and do the same 1.2 millimeters, only 2 walls instead. So 3 walls versus 2 walls with a 0.5 nozzle. But I'll typically just use a, oops, I guess it's homing before it loads filament. I gotta check my macros. Good to see that still homes. Oh, I'm also running a modified homing override, actually based off of the tap changer. Because I'm using sensorless homing, I'm changing the current that it homes at. I'm homing at half the current that the motors are set to. So right now, the motors are at 1 amp, and I'm homing at 0.5 amps, just to increase the sensorless resolution. Why not go smaller and smaller printer? Because most models are designed for 0.4 millimeter. Most files, most STLs are designed to be used with a 0.4 nozzle. That's just kind of what it is, right? Like most of the things you see in here are easily printable on a 0.4. There's still enough detail to where you can print small things, but the smaller the nozzle size you go, the more flow restriction there is. A 0.2 nozzle is, you're probably limited to 5 millimeters cubed, maybe. Very, very low flow. Go on here. Are we actually loading filament? Let me just do it the old-fashioned way. Extrude. There we go. Load it in. I can set up all the macros for it. We should be good for now. And yeah, you can use a regular nozzle, and this is a fast printer. So with Dragon Burner, we get pretty good cooling, and it's running a Fadus Rapido, so we have high flow. So we should be able to print at pretty much maxing out the capabilities of PLA. Do you have any experience with Slice Engineering? Picked up a Gamma Master nozzle for Prusa. Nozzles, you really have like your different types of nozzles. So brass, copper, tungsten carbide, regular hardened steel, diamond, etc. Like those are your main different types of nozzles. And then within them, it's either a high flow nozzle or a standard flow nozzle. A high flow nozzle has some additional technology to increase the flow. Most commonly, we'll refer to high flow nozzles as CHTs, but there's a lot of other high flow nozzles too that are not CHTs that kind of use the same technology. So I don't have any specific experience with that nozzle, but it's probably fine. Lost in Tech actually has a new video up. I could post a video in the description new to the time of this recording, but he has a video where he's actually exploring the internal geometries of nozzles via cameras, and it is super cool, super exciting. So make sure to check that out. 1.8 CHT, yeah, I print decorative stuff mostly, even if it's functional, I want it to look good. So I'll use a 0.4 nozzle for that. So our filament's loaded. Z offset isn't set for the for this PEI, but we should be able to still send the print to the printer. So let me just send it over and see what it does. Will it print? Will it blend? Tune in to find out. Hello, Major Gamer Geek. How are you doing? One of my favorite nozzles is actually from West3D. It's their Undertaker nozzle. Actually, they sent me a sticker. I can show you that. Here it is. Undertaker tungsten carbide nozzle. So this right here is a pretty much the same performance as a brass nozzle, which is fairly good. But it's indestructible. It's essentially wear resistant. We'll call it wear resistant, not indestructible. If you know, you know. But it's a wear resistant nozzle you can pretty much put any material through. You can put 100 kilograms of abrasive nylon through it, and it probably won't wear it out at all. It's an incredible material, and it works great for nozzles. So I've been recommending just buy one nozzle, buy a 0.4, maybe 0.5 Undertaker, and call it a day. Are we printing? Let's see. Oh, yeah, okay. There we go. Had to heat up the bed, which takes about 2 seconds. That was crazy. Tungsten carbide filament. That's funny. Yeah, west3d.com/zombiehedgehog, and then type Undertaker, and that'll get you to their nozzles. I mean, I purchased quite a few of them, and then of course West3D has sent over a couple. If I don't know what nozzle to use on a printer, I'll typically use one of those. I've also been experimenting with some cheaper high flow nozzles off of AliExpress, and those work pretty well too. But for abrasives, I'll typically go with the tungsten carbide. Let me get this centered a little bit more. So right now it's doing a quad gantry level. It has 4 independent Z motors, so it's able to do this special tilting and get it level. Nozzle car. Oh, I have that plate somewhere actually. Is it still here? I think I saved it. But yeah, I have a plate for my Death Racer that's just covered in Undertaker nozzles. B stock, but they're still tungsten carbide nozzles. I have no idea where that went. No idea. It's around though. Tungsten carbide CHD. That would be something like a Basel. But I don't even know if you can buy them anymore, to be honest. But yeah, that would be ideal. Some type of a high flow tungsten carbide nozzle. But nozzles are their own very, very interesting thing that I am currently not qualified to fully talk about. I can share my experiences with, but there are some people that know a lot more about nozzles than I do. So right now I just did a 25 point bed mesh. Way too much. Eventually I'll install camp on here, so it just probes where I need to. But when I set up a printer, I like to just have it probe the entire bed, so I can check the height map in Clipper and see, okay, yeah, that's looking fine. Or maybe, hey, we need to improve it a bit. Hey, Silent Assassin. Have I tried the Dragon Ace? Yes, I have. Very briefly. It seems like a pretty good hot end. Actually, I forgot I had that. It's on my Rook 180, now known as, not a Rook 180. What is it? Bastion? Yeah, maybe Nick. I don't know how that works, but maybe. I've not tried that. So it looks like we are printing. We're just printing a swatch truck. And looks like the Z offset is sufficient. Because we've already set the Z offset to the Kapton tape, it's going to work out perfectly fine for this. Might need to change it slightly for the texture PEI though. You have to drill it out. Yeah, see, you can't really drill out tungsten carbide. That's the issue. That is an issue. So it looks like on the overhead. And there we go. That's kind of what it looks like when it prints. This is how I've wired it. I don't know what the final version of the toolhead wiring is going to be like, but for now I'm just running it like this. So more information on the wiring on West3D's website, or on their Discord, or maybe on my Discord, but I do not know what they're going to be including for final wiring. They should be pretty close to this though. Yeah, that's just a swatch truck, and I know it's going to print perfectly fine, so that's awesome. It's nice to know. Now, if you're building this from scratch, you'd use a swatch truck to check your overall flow. So we'll be able to see at the end, can we spin any of the wheels? How is this top surface looking? You'll be able to tell if you need to adjust your pressure advance settings, your first layer squish. It's a pretty nice little test. I developed this print and I've used it for many printers. It's really nice. How do you know the size of print bed you need to buy? Well, what do you have for your printer? So as this prints, as you're watching it go, make sure to hit that like button over on YouTube and subscribe to my channel if you haven't. I do have merch. It is really nice merch. These shirts are extremely high quality and super soft. The hats are custom embroidered, and they're available in multicolor embroidery. So it looks pretty awesome. So make sure to check them out. Ah, focus. Focus. Just push the printer closer. There we go. There we go. It's slightly tilted. I'll fix it. I need like an auto leveling camera. That'd be pretty cool. So what can you print on this printer? Well, it's 180 millimeters, so you can print something like my Outrun tray right here. This is a 170 millimeter print. That'll print perfectly fine on the printer. And then height-wise, it's 150 millimeters. At least this one is. So let's just say 150. That is this amount right here. So you're not going to be printing super tall things with the stock config. For example, these swords by 3D Printing World. So that would be just shy. You'd have to scale it down. Hypothetically, if we didn't have a top hat and if our cable chain extended, we should be able to get a full 180 out of it. So I actually am planning, and if you're interested, leave a comment down below. Are you interested in seeing a conversion to a top hat so we can get more Z height out of here? I think it'd be great for printing most small things, or multiple small things at once. Let's see a top hat conversion. Okay, so what that would be is either printing. You can have printed extensions. Actually, I could probably just print the entire top hat. So I'd have to see, you know, how much the wiring sticks up, how tall it would need to be. But it's very possible to just print off an entire top hat. You wouldn't even need to buy extra panels. You'd have just a blank panel, essentially. You can add some fancy patterns to it, but it would be a blank panel that you print. maybe 2 pieces that overlap with some corner brackets, and then the stock top panel would go on the top. But yes, this is the Micron Plus. This is the West3D kit that I built as a beta. And I have a special plan for this after the beta is over. So tune into Twitch if you want to learn more about that. So what I might do is, if I'm going to build a top hat, I'd like to build it, I don't know, a little bit more clean. So I'd use the same extrusions. I do believe these are DLL PDF extrusions. So I get a whole nother set of extrusions for the top hat, and then purchase additional panels. So maybe just a set, kind of like a V0. It would look exactly like the V0 does. That is a top hat right here that folds up. So it has 4 clear panels and then the top panel right there. So I'm thinking about incorporating that same thing to this build so we can have some extra Z height. Because if you can get this thing close to 180, that's pretty tall. And a lot of things will fit on there. But I just like having a little bit less restriction than the V0 has. I mean, I can print my hex my organizer in here. You might be able to print a hex tray on there. Want to see builds? Yeah, so if you're building this from scratch, you could actually buy a frame and then just extend the extrusions up. Nothing's stopping you from doing that. Oh, and we lost adhesion. I might not have had enough squish in that first layer, so let's see what happened. F's in chat. Let's see. Yeah, I definitely need to be squished more. Throw it away. All right, yeah, all right. It's time to make a new printer. Hey, we got pretty far though. So looking at the Z, does look like it's pretty good flow. It looks like my flow is actually way too high. That's an issue. So my flow is too high. So I'll have to reduce my flow, increase my squish, and then restart. But hey, pretty good. This is texture PEI, so I was expecting to do a little bit more squish. It prints. It prints. I might actually increase my bed temp to 60 as well. So start at 65 and then go to 60 just to make sure that the bed temp isn't the issue. And I should probably clean that plate. It's brand new. I haven't even printed on it yet, so cleaning the plate would be a good idea. And I'll actually use Maker's Mistress on it too, another one of West3D's products. It's just their kind of glue stick in a bottle, that's what I call it. So let's apply some of that on there and then restart the print. Hey Wolf, how's it going? So let me give it 0.25 extra squish. Put a PI sticker on the glass print bed. Glass print bed. Glass print bed. What year is it? All right, let me see. Let me go back into here and adjust. So the flow looks like it was a little high. Ideally, you'd want to run the full set of calibrations in Orca Slicer, but for now, we're just kind of getting a rough start. So we'll go to 0.92 flow, and then we'll increase our second layer to 60C. And then we can actually, we'll keep the volumetric flow at 18. It looked like it was able to extrude fine at that. We can actually increase it to 20. This is a high flow Rapido. So we should be able to. We're gonna test that. And then pressure advance actually looks like it is fine. So we'll keep it there. All right, let's reprint. Oh, I should probably quickly apply the adhesive. So quickly spray off with isopropyl. I spray a little bit of this on there. Give it another hit with the isopropyl, and then rub it in. The isopropyl keeps it kind of in its liquid state for as long as possible. The bed is also heated, so it doesn't help. But you're really just kind of spreading around a nice, even first layer of what's essentially a liquid glue stick. And that'll help with some adhesion. Especially when you're printing ABS, I find it's nicer to have that versus not. I guess I can see it like this. I think I didn't hit print either. It's like rushing to do it before it started printing. So I'm very impressed. Oh, I paused the printer. Right, okay. That's what happened. I'm very impressed with how fast the bed it takes to heat up. That's really nice. So when I enclose it, if I want to print ABS on here, I'd be able to go pretty fast and just print some ABS. Kind of like the V0, but I think the heat up time for the bed is less than the V0, so you can potentially start printing faster. Now the V0 doesn't require a bed mesh, this will, so you know, your mileage may vary. So it's gonna do its homing routine. Sensorless X and Y, probe mill the bed. I think it heats up the nozzle 2 to 150 to make sure that any filament on there is squished. Then I'll do a QGL, make sure that the gantry is lined up. Haven't really adjusted the points for that, so I don't know if it's actually probing correctly. Who knows. But it's probing pretty consistently right now. Not fully broken in yet either, but it should be getting there. Some filament scraps in the middle of the bed. Don't touch the bed with your fingers, because you'll just have to re-clean it. If anything, use your fingernails if you have to touch your bed. Be careful. Now we can do a full bed mesh, 25 by 25. Because why not? Yeah, I really gotta install Camp. Camp, if you don't know, is the Clipper Adaptive Mesh and Purge. It'll do an entire analysis of the size of the print, and it'll only probe in that area. And then it'll do a purge right in front of your print, which is pretty nice. So Modbot has a good guide on how to install that. What's my lift speed set to on here? Seems pretty slow. Max sleeve velocity 200 millimeters a second. Let's see. Let's see. QGL. We have 10 millimeters horizontal move, but the speed itself, I think it's under the bed mesh. Mesh speed is under probe. Speed 30. Oh, I don't have a lift speed set. Okay, I want to do that. So I'll typically do a lift underscore speed in Clipper, and this is a 2.4, so lift speed's around 150 millimeters a second. Because it's belted Z, we can go very fast. One of the main reasons why you'd want to build like a switch wire is so you can get that faster lift speed. And I'm using the 0G start macro just for now. And I'm going to take a closer look at that first layer to make sure that it doesn't need additional squish. I really have to go on the front, but let's see. Looks good. I might need a little more. Just a tiny bit more. Go minus 0.1. There we go. Swatch truck. Take 2. So we're going to take this build. It's not quite done yet, but it's essentially done. So I'll be doing one more update video after it's fully enclosed and printing ABS. I'll show the wiring and any last-minute updates. Think a stream just talk about tools would be a good idea? Yes, absolutely. That would be a great stream for YouTube. I'd also like to make a video just going over what tools I use, but maybe we can talk about that on a stream first. I've been working on this printer off, on and off stream. I wanted to get as much possible done before the heater came in, so I essentially built the whole printer, and I've been tuning it. Fun fact, I didn't have all of my tap PCBs, or the octo tap PCBs for my my tap changer, the Voron tool changer. So I actually stole the one from this. All the tool changing I've been doing has been using this sensor. So I finally just replaced it the other day. I put it back in here. It's still working, that's good. But yeah, this printer saved my progress on the tap changer. Been able to print off some pretty cool things. So if you're interested in the Voron tool changer, which is behind me, I'm able to do stuff like dual color prints, like this sword right here. The actual hilt is in 2 different colors, prints at once with no waste. So those are some of the fun things I've been doing. You can print them separately too, and then print your own sword part. Yeah, these are really cool. I actually just like printing the hilts just to have. Pretty cool. But yeah, I'm gonna be printing off lots and lots and lots of cool multicolor things, so make sure to take a look at that build series, which is on YouTube, and I'll have some future videos on that as well once we finish adding all the tools. So if you'd like to see more crazy, awesome builds like this, and actually, if you have any suggestions, what would you like me to build on this channel? If you could choose any printer for me to build, within reason, what would you like to see? And I will take serious consideration. Give me a good explanation of why. Like, you want me to build a Voron Phoenix? Okay, why? Why would I want to build a 600mm printer? Let me know. What would you use it for? If you want to build a really fast printer, if you want to build more tool changers, let me know in the video description, in the comments below, not the description. So that will be all for today. Again, tune in live for Twitch, where you can see almost daily printing and discussions. We're always streaming over there, 10 o'clock Eastern time when I'm streaming. We have the Z and Z show on Mondays at the same time. With me and Pezliz, we talk about different makes we've done through the week and different 3D printing topics. And yeah, I'm just looking to expand this channel in the future, so stay subscribed, stay tuned. Make sure to pick up this kit at west3d.com/zombiehedgehog. I have the links in the video description. If you have any questions, let me know. So thank you for tuning in. We'll have probably one more update on this. Bug me if I don't. Otherwise, have a good night. Good morning, good evening, and goodbye.